Hello everyone, this is the demo for online path planning using RRT with anytime algorithm and lazy collision evaluation algorithm. Presented in this paper, online path planning for autonomous underwater vehicles in unknown environment. I have implemented RRT with two additional concepts named anytime approach and lazy collision evaluation. RRT is rapidly exploring random tree which is an algorithm designed to efficiently search non convex, high dimensional spaces by randomly building a tree. They easily handle problems with obstacles and differential constraints and have been widely used in autonomous robotic motion planning. So let's start demo by running the implementation code. I will go through each step to give you the clear picture of what is happening. So I have implemented this first step of RRT without any collision checking, and if you see over here it is passing through this obstacles for building this random tree. So as soon as it reaches to this goal, it gives us this valid path from start to goal, which is also passing through this obstacles, which is not valid in real world. So for second step, I have implemented simple collision evaluation for nodes in this extend tree process, and this is a demo for the second step. Now we got rid of those paths in which nodes were colliding with the obstacles, but still there are some branches of the trees over here which are colliding with obstacles. If you see, this branch is also colliding over the obstacle. And at the end of the second step, this is the final path from start to goal which we get. But in this path also, this is the branch which is colliding on the obstacle, which is not still valid for real world. For this flaw, the paper says that they implement update tree process to discard such branches in the RRT while extending it further. I have also implemented this step by implementing update tree process. Here is the demo for advanced collision evaluation for branches. Now if you see over here, there is no collision between such branches and obstacles. And at the end of this third step, here is our valid path from start to goal. One of the main concepts discussed in the paper is anytime approach for path planning. Anytime algorithms give us output path anytime, even if we interrupt our algorithm in between. In my implementation, I have considered cost function for computing this best solution. So whenever we interrupt the code in between, it will give us the best path found in terms of cost till the end of interruption. Before jumping to the demo of anytime approach with RRT, I will like to show you this new version of RRT for finding optimal paths in term of cost. So as soon as it gets some minimum amount of paths from start to goal, it will show us those paths and the best path among them. So this is the best path among 5 paths shown in green, and these are the other 4 paths in red. If you see, this has more eight branches than this one. This one is even longer than this one. This one also have extra branches than this one. And this is the last one. Now, if we want to check anytime behavior of this implementation, I will run this implementation code again, and we have to interrupt it in between before we reach till end. So I'm interrupting it in between, and if you see, we have got this best path shown in the screen till now, and these are the other paths shown in red, which are also generated before interruption but have greater cost than the best one in green. So these are total three paths which were generated before the interruption, and this one is the best one which we got in green. So till now I have implemented anytime approach with standard RRT and advanced collision evaluation for branches and found the most cost optimal path. For advanced collision evaluation for branch, I am checking the collision with many points which falls between two nodes, and this is done for all the branches while extending the tree, even if the branch may not be included in one of the valid paths. Hence, I have decided to implement the second approach, which is lazy collision evaluation mentioned in this paper for branch collision evaluation. So while growing tree, the branches with collision are included and considered valid. But when we have some 5 to 10 paths from start to core, we will check the collisions for those paths only while exploring it, and will give the valid minimal cost path from valid ones. And that's the end of this demo. Thank you for listening.